Okay, so welcome back. Now, let's start by looking at the slope of a line. Okay, so again, so we have this parameterized curve, right? So this is, again, it's parameterized. We've got our x sub t and our y sub t. And so, again, what we have here is from -3 to 2. Okay? And so when you plot it, and again, you get this straight line. Again, we're using a very simple straight line, linear line, for the purpose of showing you how this works. Okay? And so now what we're going to do is we're going to basically eliminate the parameter. Okay? So let's do that. So we're going to solve for 1. So let's x, or excuse me, t. We want to solve for t. So we're going to solve for the first one. So we get t equals x minus 3 divided by 2. Okay, then we're going to substitute that into y. So we get y equals 3 times x minus 3 over 2 minus 4. And so if we simplify this, what do we get? We get y equals 3/2 x minus 9 minus, or excuse me, hold on, slow down. We get minus 9/2 minus 4. Okay? And so if we simplify this even further, we get what? This is going to be 8/2. So minus 9/2 minus 8/2 gives us a minus 17/2. Okay? Now, notice that the slope of this, right? So again, if we look at dy dx is going to be equal to 3/2. Okay? So we know the slope of this line is 3/2. Okay? No problem. Right? Okay. So now let's look at the parametric equations. Okay? So what is x prime of t? Well, x prime of t, with respect to t, is going to be 2. Y prime of t is equal to 3. Okay, so notice something here. So this, what is this? This is just equal to dx dt, right? And this is equal to dy dt, right? Both of these are the derivatives with respect to t. Notice that, what do we get here? What if I take the change in y, right, over the change in x? So the derivative of y with respect to t, so dy dt divided by dx dt will give me the same thing I get, which is when I do dy dt, which is equal to 3/2. And that's not by coincidence. Okay? As you're going to see in the next theorem. Okay? There is a direct relationship, and so in the next video we're going to introduce a theorem that puts this all together for when you were dealing with slope and using calculus when it comes to parametric equations. See you then.